Good evening to all of you. Thank you so much for coming and joining us. I'm Alison Potter. I am the Communications Person and Council Liaison for APVI and SunSPOT. And with me tonight, we've got Dr. Anna Bruce, who is one of the builders of the tool. She's waving at you right now. She is the SunSPOT project lead. She's a renewable energy expert. And we've also got Ellie Kalmia and Russell Kindler, who are also experts in their own right. They are research assistants with the APVI.
Indeed.
So SunSPOT, just to get started, is a project of the Australian PV Institute, which is a solar research institute. It's a not-for-profit, and UNSW. SunSPOT has had funding from a number of Australian governments, the New South Wales government, ACT government. We've also had funding from ARENA, the Australian Renewable Energy Agency, and also ACAP. But our version 3, which is the current version which we've got now and is really quite significantly improved, has been funded by the federal government and will also be promoted by the federal government a bit later in this year. And what we're going to cover today in this webinar is part 1, that's how solar works, how it can save you money, and also, importantly, how you can improve the savings. And part 2 will be how to use SunSPOT and what it will tell you. And then we'll have a Q&A where we'd love to hear all your questions and help you out. I'm probably going to hand over right now to Russell Kindler, who will very ably introduce you to solar.
So yeah, thank you, Alison, for introducing me. To begin with the solar journey and how SunSPOT fits into this, we'll start with just the basic description of how a grid-connected solar PV system works. And as you can see here, we've got sunlight, which is going into solar panels, which convert that sunlight into DC electricity. This then flows to an inverter, which converts it to usable AC electricity. And so when the household uses appliances or you use electricity inside the house, when the solar is being produced, it consumes that solar into the house. When there is excess solar being produced, that then gets exported to the grid, and that is what you receive a feed-in credit for. We'll touch on this in more detail later. When the solar or when the house is consuming more power than the solar is producing, or when the solar is not producing, like at night, the household consumes its electricity from the grid as you would in a normal household. There are several factors that can impact the performance of PV systems. The first being the amount of sunlight, which varies due to seasons, location, and weather. Next, we have the tilt and orientation of the panels towards the sun and how that impacts it. We also have shade on the panels. We have dirt in some cases, faulty wiring or an inverter fault. There's also damage and degradation, temperature, and in some cases, curtailment. Now, let's take a closer look at some of these factors. So firstly, when it comes to the orientation of the panels, we have north-facing panels receive the most sunshine hours and therefore produce the most electricity. East and west-facing panels also give acceptable performance, and they favour production in the morning and afternoon, respectively. And as you can see there, we've got the morning sun, so panels on the east side get that morning sun, and in the afternoon get that westerly sun. And as you can see, northerly here with the sun beholden for the most throughout the day. As for the tilt of the panels, solar panels are most productive when they are tilted to face the sun. The optimal tilt or angle is similar to the latitude of the location in which the system is in. For example, in Brisbane, we have a tilt or latitude that is at 27.5 degrees, Sydney with 33 degrees, Melbourne with 38 degrees, and Hobart with 43 degrees. And you can see that that tilt angle corresponds to that angle below the panel where it meets the surface that it is mounted upon. And now for the question of flush or rack mounting your panels. So flush meaning when it's flush with the roof and flat on top of the roof, and rack mounting meaning we use tilts like you can see in that photo there. Conveniently, in Australia, most roofs are between 15 and 30 degrees, which is very adequate for flush mounting of the panels. In the case of a flat roof, mounting the panels on racks to tilt them towards the sun will improve their efficiency, and it also helps with rain, keeping them clean, which is the same for that panels flush mounted on a pitched roof where the rain washes off the dirt, which is one of those factors that impacts performance. Adding tilts to your panels will increase the cost of the overall system. And now for shading. So if your roof has significant shading, the standard string system may not be the best option. Shade on one panel will lower the output of all panels in a string of panels connected to the inverter. As you can see here in this diagram, we've got shade reducing the production of this first panel by 50%. And since these panels are all strung in the same series circuit connection, all of their production is decreased, reducing the overall production of this system. Luckily, there are several options that solve this shading issue. These systems allow each panel to avoid being impacted by shading on other panels. These are more expensive, however. Some of these options include microinverters, which are inverters on each panel, as opposed to that string inverter in the previous diagram. You have DC optimized panels and power optimizers, also known as TIGOs. And as you can see with these solutions in the system, you can see that 50% reduction from shading only is reducing the production of that one panel, whereas the other panels, unshaded, are producing at 100% capacity. So now for tips for choosing the right hardware. So first and foremost, the inverter is the most common point of failure. So we recommend spending the money to get a good quality inverter. Also, you have poor quality panels, which can then degrade faster. So this is another point of spending a bit more money and looking for these quality products. Ways to look for those is by buying CEC approved products. You can also look for products with longer than the minimum product warranties and a good reputation from support from an Australian office of the manufacturer. A good way to go about this is to read reviews about products and companies online. Also, a huge point of question when purchasing a solar system is choosing your installer and receiving these first quotes. And so we've got these 10 tips that we recommend checking off on your way to getting solar. The first would be ensuring that the solar sales company you talk to is an approved seller with the new Energy Tech consumer code. You should also ask who will be installing the system. It could be a subcontractor, and you should check that they are accredited with the Clean Energy Council. Also, you want to search for online reviews about the company and read the bad ones. Some companies reward customers for good online reviews to get a large flow of good reviews. And then also, do not be tempted by very cheap, heavily advertised systems. This is likely to translate to poor workmanship, problems with the system after installation, and poor customer service later on. So fifth, we have seeking out a local reputable electrician who specializes in solar installations, who is accountable to their customers, is worthwhile to get a quote from. You can ask your neighbors with solar for recommendations. Also, you should look for companies that have been in business for many years and have technical and sales support in Australia. This applies to the installing company and the manufacturers. We also recommend getting at least 3 quotes to compare between. Also, beware of installers who swap the quoted brand for another brand. We also heavily recommend checking your quotes against your SunSPOT estimate. Ask about any big price differences between your quotes and the SunSPOT estimate, because there may be good reasons. For example, SunSPOT cannot see what's happening inside your switchboard, and this is something that might need upgrading to get solar on your roof. There also may be long cable runs, or the access might be difficult. The installer or seller should be able to explain these. And lastly, check the warranties. So there are 4 types of warranties in solar. A, B, and C are the most important. A being the installation warranty from the installer, which covers any faults or faulty installations from the installer. And this is important and might be between 1 to 10 years. The longer, the better, of course. B is the inverter warranty. This could be 5 to 10 years. The longer, the better, as the inverter is a frequent point of failure in a system. C would be the solar panel product warranty, which is nowadays often between 20 to 25 years and worth looking for, because if the panel stops working, this is the warranty you rely on here. And lastly, of less importance, is solar panel performance warranty. These are typically 25 years and as a standard and are less critical. They cover the degradation of panels as they age, but they do not cover faults. Now for rebates. So Australia-wide, from the federal government, the STCs exist. These equate to around $396 per kilowatt installed, or $2,592 off a standard 6.6 kilowatt system. These rebates are included in quotes and advertised prices, so there is no need for you to apply for it. SunSPOT estimates include these, but SunSPOT does not include any of the state-based rebates because these are constantly changing. We will actually, at the end of this presentation, send out an email with all the information on the state rebates and places to keep up to date with those. And so now, for the next stage in the solar journey, is how does solar save you money? There are 2 main mechanisms in which solar saves you money. The first and most important being self-consumption, which is when you use your free solar during sunshine hours in your home and you avoid paying pricey retail rates for electricity from the grid. And these, as a lot of people know, are going up on the 1st of July this year. The second mechanism being less important are feed-in tariff credits, which is when unused solar is sent to the grid, and that earns bill credits from a feed-in tariff, which are now typically between 5 to 10 cents per kilowatt hour. So now we're going to go through an example of good solar self-consumption and an example of poor solar self-consumption, equating to less revenue or a slower payback of your system. And so what we have here is we have a graph which follows the load profile of a household. As you can see, we've got a bit of appliances being used after midnight. It's dipping and then peaking again at about 7 a.m. where someone's possibly turning the kettle on. And then we can see the bulk of the electricity load in this household exists throughout the day. When we overlap a solar system on top of this, we can see that solar PV curve, the nice bell shape, as you can see here. And the yellow is the free solar electricity, which is generated when the sun is on your panels. Coloring this in, we can see how this breaks down into your electricity bill. So what we can see here is that the green highlighted shape of that curve is solar that you are self-consuming in your house, and this is saving you at your grid consumption rate. For this example, we've used 30 cents per kilowatt hour, whereas the feed-in tariff, which is the solar that is being unused by your house and that is getting exported to the grid, is you're getting paid 5 to 10 cents per kilowatt hour. And so in the case of 10 cents per kilowatt hour, we can see that self-consumption is triple the amount that you're receiving for that export. So it's extremely important to shift your load, or as much of your household load, during the day to those solar hours to earn the greatest revenue possible from your system. Now we're going to go through an example of poor solar consumption. And as you can see, this household is using very little electricity throughout the day, and you can see this big spike of electricity in the evening. Overlapping the solar graph or the solar production curve with this household load curve, we can see that there is a much smaller self-consumption of that solar here in that green shape. And as a result, this customer is earning less on their system, and therefore the system will be paid back at a slower rate. So as I just touched on, maximizing the self-consumption of your free solar power gets you the bigger savings. For example, a Sydney household with a 5 kilowatt solar system on the roof self-consumes 25% of the solar power at home during the day and exports the remaining 75% of their solar to the grid. This will take, on average, 5 years for the 5 kilowatt system to pay for itself. However, if they can increase their self-consumption to 50% and then export only the other half of their solar production, it will just take 4 years on average for the system to pay for itself. So how do you maximize solar self-consumption? The first and most important point to do is to move as much of your energy use to between 10 a.m. and 4 p.m. in summer and 11 a.m. and 2 p.m. in winter. There are various ways you can do this, but the key loads in a house and ways to do this is by setting timers or manually running the following appliances within these hours. And this includes home heating and cooling, hot water heaters, pool pumps, washing machines, dishwashers, clothes dryers, etc. The second technique to do this is to replace gas appliances for energy efficient electric ones. Now for bill credits from the feed-in tariff. So feed-in tariffs are low, up to 10.4 cents, and compared to retail electricity prices, the credits from them can accumulate over the summer months when more of your excess solar power flows into the grid, especially if you have a larger system. These credits then help offset your electricity bills in the following winter. Now for export limiting, in many parts of regional and rural Australia, there are limits to how much power you can export back to the grid. These limits vary in each state. If your system is expected to export more than the allowed amount, you may be required to purchase additional hardware to control your system's output. And so now, how much solar do you need? So sizing your solar system generally depends upon several factors, with the first and foremost being how much electricity you use, the next being your future electricity needs, implying switching from gas to electricity for cooking, heating, hot water. You could be buying an electric vehicle in the future, getting a pool, air conditioning, or purchasing a battery. Also influencing the size of your system is your suitable sunny roof area, and lastly, your budget. And so now, SunSPOT will recommend a system size for you. If possible, SunSPOT suggests a system size that will pay for itself in savings in under 5 years. This is based on the estimated electricity consumption and the electricity costs for the household. So now to go through some of the details of SunSPOT. So first and foremost, there are two versions of SunSPOT. We have the premium and the standard version of SunSPOT. So the main differences are, so standard SunSPOT is freely available everywhere. It does not need the local council to have a subscription or the area to be mapped with LiDAR data. You're going to get a bit more of an insight from the LiDAR data when Ellie goes to the live demo, but the LiDAR data is used to develop a 3D model of your roof, which then can automatically read the slope, the shape, and then the degree of shading on that roof to then equate to an accurate estimation of how much solar production a system on your roof will create. And so the standard version of SunSPOT does not do that, and it requires more inputs from the user. The premium SunSPOT requires a subscription by the local council. This needs suitable spatial mapping LiDAR data, which I just touched upon. And this provides the most accurate estimates and does not require inputs from the user, which include that tilt of the roof, shape of the roof, and the degree of shading. At the end, we're going to touch upon a link that we will send to you guys that will help with an email that you can send to your council to request a premium SunSPOT subscription. And throughout the demo, Ellie will show the main differences and how you can tell if you're on the standard or the premium version. So now for what can SunSPOT do? So SunSPOT version 3 estimates the system size and the savings from solar and batteries for households and businesses by taking account of the on-site electricity consumption and costs, the roof size, the orientation, tilt, and the shading, local weather data, and your budget. SunSPOT provides independent answers to the most common consumer questions about solar and batteries. These questions include, what size solar system do you need? How many solar panels will fit on your roof? How much money will solar save you each year? And then another one is, how long will it take for a battery to pay itself off? There are many other questions that SunSPOT will answer. Ellie will touch upon these in the live demo. A quick disclaimer as well, important to note, is that SunSPOT is a not-for-profit and your details are not shared with any sales companies. So now for the live demo of SunSPOT, I'll pass it to Ellie, who will show you.
Hey everyone, thanks so much, Russell. So I'm going to take you through the SunSPOT tool itself. And the first place you can see, we're starting on SunSPOT's website. So we have this beautiful website which Alison put together, which has a whole lot of really useful and important information about SunSPOT, including a bit of extra help on how to use the SunSPOT tool, and also some of those links to help email your council and some information for your local councils, and also about the calculations we use and why you can trust SunSPOT. So once you've had a look through the website, you can click through, grab an electricity bill and try SunSPOT now, and it'll open up into a new tab, the SunSPOT tool itself. So first up, you can see a quick overview of the tool and what it's going to help us do. And once you've had a read of the full conditions of use here, we're going to go ahead and click agree and start. So on this first page, let's say I'm living at a property 522 Illawarra Road in Marrickville. Oh, that's my keyboard going a bit funny there. 522 Illawarra Road in Marrickville. And if you take a look at this drop down, we have a choice between residential or commercial for this property type. We're just going to stick with the residential property type in today's demonstration, but the commercial property type here just leads you down a couple of different onboarding questions. The rest of the SunSPOT tool is pretty much the same in terms of how it functions. So if you know how to use it for a residential property, you'll know how to use it for a commercial property. So once we put our address in, we're going to go ahead and click find property. And at this point, we can see, okay, I know that this property here is the one I'm looking for. And it's asking us a first question about our electricity usage. So at this point, I can either grab my latest bill to find some of these numbers, or I could click I'm not sure. So let's say I do have my latest bill, and on average, it says that I use 15 kilowatt hours a day. And that bill was for the period between, let's say, last September. So we're going for a spring bill. So the start of last September to the start of December. So you can see that there's a couple of different options for inputting the dates here. You can either type it or you can select from the calendar. And I'm going to go ahead and click next. We'll say there's 4 of us living in this house. So you can see we've got a slider here and the house has a gas connection. All right. Now I'm asked about a budget that I want to spend on my solar system, but I haven't thought that much about how much I'm prepared to spend on solar. So I'm going to go ahead and click I'm not sure. Now, once we hit this calculate button, SunSPOT is taking all of the information I've just given it and running a couple of key calculations. So first, it's estimating my household's load profile, which is a word you've heard us throw around a lot. And basically that means how much electricity the household uses and at what times of day. So the questions that SunSPOT asks in the onboarding stage help it to understand which sort of appliances you might have in your house. So I've said that I have gas in my house. And then it creates an estimate of sort of when I might be using that electricity based on those input questions and a bunch of other information that we've done a lot of analysis on from thousands of other households. SunSPOT also creates an estimated solar generation profile for a system on our roof at this address, which helps us calculate these bill savings, which you can see here. So this is the first page that you'll come to once you've answered all those questions. And you can see we've got a couple of interesting features here. So the first I want to draw your attention to is this suggested system size, which Russell touched on. And it's suggested to pay back your system within 5 years if possible. We've also got an estimated system cost, which you can see as a range. And that's just to reflect, we know there are a range of prices that the same size of solar system can cost based on whether you have to have these extra things like a tiled roof or extra access or that kind of thing. And this is also reflected in the range for the payback period that we give here too. And so then this quantity here is showing what your new electricity bill would be with this solar system size. And here we can see the annual bill savings and an estimation of the reduction in our greenhouse gas emissions from electricity use. So I just want to stop here and just say, this is all you need to do. If you're only interested in getting a really high level sort of estimate of what solar might look like on your household, you can stop right there. You can download the estimate to take to some installers that you want to grab quotes from, and you don't have to go any further. However, we can add a heap of extra information about our household and our electricity usage and our roof space as well to get a much more accurate estimate of what benefits that solar is going to have for us and for our household. So now I'm going to jump into the next important step, which you might want to give a shot at, is mapping your roof. And that means mapping the solar panels onto your roof to make sure that they're going to fit and to see how many you're going to fit and to find out what areas of your roof are going to suit solar. And this is where we'll see the key differences between that premium and the standard version of SunSPOT, which was touched on before. So because we're looking at a property in Marrickville, which is in the Inner West Council in Sydney, we know that this area does have the LiDAR mapped data and the council is subscribed to SunSPOT. So this demo is going to be of a premium version of SunSPOT. And in a second, I'm going to jump over to a standard version just to show you some of those differences. So the step one in this mapping process is just to make sure that we can see the roof on our screen. We can see it here, but it's pretty small. So I'm going to zoom in just using these buttons up here. And then I can just click and drag to make sure that the roof is nice and centered. And I can see the whole roof and a little bit of the surrounding area as well. There's a couple of choices for imagery here. And we recommend that you choose the set of imagery that has the most up-to-date view of your household and the surrounding areas. This might be the state government imagery or Google Maps. And in some scenarios, there may not be state government imagery available. So you'll only have the Google Maps option. So then step two is where things get really fun. We have some rainbow dots overlaid over our house, and these dots are correlated to the LiDAR data that we have. So the premium version gets the rainbow dots, and sadly, the standard version does not have rainbow dots. So SunSPOT uses that 3D spatial mapping LiDAR data to read the slope and orientation of a roof area and to assess the impact of shading on that area from nearby structures. So we can see that these darker areas up here, they're shaded by some trees from the north, and we can see that these red areas here are getting some really good sunlight. So red means the most sunlight, and these blue means the least sunlight. And we can change how bright those dots are with this slider here. And I'll just note, there's a little toggle here that you can switch if you see dots in your area, but they're not covering your roof. So you can see there's no dots over the street here, that's fine, but our whole roof is covered by dots. If your roof doesn't have dots, then you're going to go ahead and click that button to make sure that all the calculations can still run correctly. And what will happen is you'll be asked a couple of extra questions similar to the standard version of SunSPOT. So we'll go through to step 3 for this one. And you can see here, now we get to actually map these solar panels to our roof. So I'm going to go ahead and click Add Group, and we can see some solar panels have jumped onto the page here. So what we can do is we can drag these solar panels around just by clicking and holding, and I'm going to position them in this really red dot space of the roof. And then we can just click and drag the white circle around the edges to align the solar panels with our roof face. And then make sure that's all nicely lined up. And then we'll use these plus and minus buttons to add a couple of extra solar panels onto our roof to make sure that we get up to the 18 suggested solar panels. So our suggested system size is 6.5 kilowatts, and that's about 8 solar panels. At the moment, I've only got 14, so I'm going to add a couple more. And then I'm just going to double check that the solar panels are all inside of one roof face, so we're not crossing over any of these lines here, over the edge, and we're sat nicely in that really bright red area. Cool, okay, so I've got 18 solar panels mapped, 6.3 kilowatts, that's pretty good. But what I'm noticing now is that actually there looks like a little bit of space for some extra solar panels. So why not? Let's give it a shot and we'll add an extra row in. And that fits quite nicely, actually. So it might be that you're curious about what difference it will make to add a couple of extras from the suggested system size. What if, for example, you're imagining your electricity bill will go up soon? So maybe you're going to swap your hot water from a gas to an electric heat pump, or you're thinking about getting an electric vehicle. You can always come back and test different arrangements of panels, add more or take some away. And then the really important thing just to note when you're mapping your roof with these solar panels is to make sure that this white arrow here, which you can click on to spin around, is pointing, we call it down the roof face. So you want it to be pointing in the same direction that you would want the solar panels to be facing. So in this case, I want it to be pointing towards that edge of the roof, and it's kind of in a northerly direction as well. Cool, okay, so we've got our roof nicely mapped. If we wanted to, we could add another group of panels, but the rest of our roof faces don't look that great for solar, so we're just going to leave it with this group. And before I hit apply to my estimate and go into the next set of calculations, I'm just going to jump over and show you the standard version of SunSPOT. So here you can see we've got the same first step. So we're just going to fit the roof to our screen. And this property is located in Lake Caday in the mid-north coast. I'm going to stick with the state government imagery because it looks pretty up to date. But then on step 2, you'll see no rainbow dots. So instead, we have a couple of tips about finding the most sunny areas on our roof. So the area that gets the most sunlight through the day, usually north facing and have little to no shading. Luckily, this property doesn't have a whole lot of really big trees or tall buildings around it, so it looks like a lot of this roof is going to be pretty good for mapping solar onto. So then we'll go into step 3, and we have the same steps again. We're just going to add a group, going to place it somewhere that looks pretty good on the roof here. And we could shift this around if we wanted to with the white arrow, but I'm going to keep it pointing in that kind of northerly-ish direction and towards that edge of the roof there. What you might have noticed is that we have a couple of extra options over here. And this is because we don't have that LiDAR data, it means we haven't read in all that information about the slope of your roof or the shading details or the orientation of your roof. So we need to give it a few more inputs ourselves. So we have a choice of kind of angles for the type of this part of our roof. And I know that this part of my roof is quite flat, so I'm going to leave it there. And then we're going to have this option to add sort of an estimate of how much shading your roof has. And if you're not sure what that might mean, you can hover over this little tip here just to get a bit of extra context. So 0% means no shading, 100% means completely shaded. Here we can see pretty much no shading, so we're going to slide it all the way back down to 0. And if this whole mapping section has gone a little bit too quickly for you, no worries. There, you can always click on the instructions button there, or in the Learn More. There's a couple of more broken down steps with information about how to use the mapping tool. And then we also have some little animations just to make sure that the interactions are super clear for everyone. So hopefully you can see the main difference between that premium and that standard version of SunSPOT. And I'm going to jump back now into our Marrickville property with the premium version. And I'm going to apply my mapped solar system to my estimate. And so we've got a couple more calculations happening. And the main thing that's happening now is that SunSPOT is collecting data about the mapped system. So those panels we've just put onto the roof. And it's collecting that data either from the LiDAR information or from your user input, depending on whether you've used the premium or the standard version. This data is then used to create a more accurate solar generation profile for this mapped system. So it's more specific to your household and more specific to the area. I'm going to drag our roof back into the middle there. Okay, so now hopefully you can see we've got a couple of changed features over here. Obviously, the system size is a bit bigger. You can see we've suggested a 6 kilowatt system size and we've gone to a 9.45 kilowatt system size. Our payback period previously was around 4 to 5 years. Now we're going up to that 5 to 6 year mark, but our emissions reductions have gone up as well. So we've got an updated version of our estimates now. And again, you could stop right here and say, all right, that's all I need to know. But I'm going to go in even a little further and add some more information to keep improving the accuracy of this estimate. So what you can see here is a couple of tabs. We're going to jump into energy usage, and you're just asked about collection of your data. So if you are happy for your data to be collected for research purposes only, never to be shared with sales companies, you can click yes. I'm just going to click no because I've done this a million times. And the first question you'll notice is, do you have smart meter data? And this basically means, do you have a smart or interval meter? And do you have that data in a NEM12 format? And you can learn a little bit more about that by hovering here and clicking on this link, which will take you to our website, which has a whole bunch of information about what that means and how to access that type of data. For the moment, I don't have that, but if you do have that NEM12 formatted meter data, then you will get the best possible estimates out of SunSPOT, because basically that is an exact measure of how much electricity you've used over the past year if you have it for that 12 months. So in this energy usage section, you can give a little bit of extra information about how you use energy around the house. I'm going to skip through this kind of first bit because we already added some bill information. But you'll notice here we can update a couple of our answers for those onboarding questions. And you'll notice here that the gas connection has now been broken down into hot water, oven or stove and heating. My property doesn't have gas heating, but we do heat 4 of our rooms with those little, electric space heaters. I've only got 1 fridge or freezer, so that's good to go. And who knows what controlled load is? I'm going to click don't know. But if you want some more information, again, you can hover over this point. All right, and I'm going to rate my dry usage as low. So I'm going to now click Save Changes. And you'll see just a little note that says the changes that I've added here have been saved, but they haven't been calculated yet. That's all good. I'm going to jump over into the next tab because I want to add even more information about my tariffs or my electricity plan. And you'll be able to find what electricity plan you're on your electricity bill. So when I'm looking at this, we have a couple of different options that are given to us based on our address, so our location. And I'm choosing the single rate Ausgrid residential tariff because I want to just have a play around and see what happens when the electricity prices go up in July. So we know they're going to go up by about 20 to 25% for New South Wales, Queensland, South Australia and Victoria pretty soon. So I'm going to just add about 25% to each of these, the charge details to see what happens. So I'll take that up to 110 cents a day. and we'll take this one up to about 36 cents a kilowatt hour. I'm going to leave the feed-in tariff the same. That's the one that Russell went over before, which is the credits you get for extra solar. So I can save these changes as well. And now that I've ticked both of these tabs, you can see those little exclamation marks are gone. I'm going to go back to the solar system, and then we're asked to press recalculate to apply those new changes. So again, what's happening? We're taking all that extra information and we're recalculating everything. So we're recreating a new load profile for the household, and we're adding that to our pre-calculated PV profile as well. Cool. Okay, so we have an updated version. Our payback period is 5 to 6.6 years. System size stays the same, and we've got a couple of updated bill savings and electricity bill information. Cool. Now you've probably been staring at these little options over on the side here and wondering what can they do for us. So let's go ahead and test out adding a battery. There's a couple of options offered here, and these are just the standard battery sizes that we're seeing on the market at the moment. So I'm going to go ahead and choose an 8 kilowatt hour battery just for fun and hit apply to my estimates. So more calculations still. And what's happening here is we're getting those same calculations running on our load profile, but this time we're looking at what happens when we add a battery. And you might know that there are a couple of different ways that a battery can be run for a household. And the way that SunSPOT decides how to run the battery is depending on the tariff or the electricity plan that you have put into the system before. So if you're on a flat rate tariff, the battery is operated to maximize the self-consumption of your solar energy. Or if you're on a time of use tariff, the battery will operate to minimize the use of the peak rate grid electricity. So in those really expensive times from the grid, you're going to be able to save a whole bunch with a battery there. Sometimes it's a bit slow running when I'm sharing my screen and streaming. It's the internet usage thing. So I thought I'll get one ready to go instead. So this is what SunSPOT, the estimate page will look like once you've added a battery onto the system. And so there's this extra little tab here with information about the estimated system cost with a battery. We've got the battery size and those bill estimates updated, as well as an updated payback period. So that's all of the information that we can add as users into SunSPOT. And now maybe we want to dig in a little bit more and see what kind of details about savings and the system operation we can see. So we're going to jump into this view system details page here. And here we just basically have a summary of the information about the solar system itself. So the total size, how much solar energy it's going to generate, the area and the number of panels. And this panel group 1 here just relates to if we decided to add an extra group of panels, say on the other side of the roof, you'd be able to see sort of the comparison between those two groups. Technical details, if you click on this little option here, you can just see a little bit more, some very fun graphs, some really interesting information about how the sun travels across your roof face and the different shading impacts at different times of the day. That's one for the super technical energy nerds. And I'll just quickly jump us into the savings details page as well. And this is just a breakdown of where your savings are coming from when you add a solar to your roof. So you can see your current electricity bill minus savings from your solar system gives you your new electricity bill. And we can see down here a really good illustration of what Russell was showing before, where we see, so we've got about 9,000 kilowatt hours of solar energy exported to the grid. So that's that feed-in tariff that we're earning money from. And only 2,000 kilowatt hours of solar energy is used on site, but we save way more with that on-site usage. So it's really worth looking at shifting your load if you are thinking about getting solar. Then we've got the same breakdown for the solar system plus the battery, so that you can compare the savings between the two. And then here you'll see a set of graphs for each season, which just shows you a breakdown of your load profile, which is that blue curve up here, then the solar generation of this solar panel that you've mapped, solar system you've mapped, and then results with solar PV and then with the battery as well. So just with that legend up there. And that is a really pretty quick run through the SunSPOT tool itself. You've seen that there's a bunch of different levels you can go to with the tool. So you can start at that really high level set of estimates, or you can go deeper and deeper by adding more information. There is no right way to use SunSPOT. So you can spend as much or as little time on each page and in whichever order you'd like. And always remember that the more information you give the tool, the more accurate those estimates will be. Yeah, so that's the live demo from me. I'm going to pass back to Russell, who just has a couple of closing points, and then we can hopefully jump into some questions and answers.
Thank you so much for that demo, Ellie. So yeah, just to go over what Ellie touched upon when she was going through the build details that you could add in SunSPOT. She mentioned NEM12 format interval meter data, which is data that SunSPOT can use to, I guess, use a highly accurate reference, as accurate as it can get your actual electricity consumption in your house, which is extremely important in getting the accurate result to do with your payback time and how much the solar will save you. So on the website, which is in the landing page, we've actually provided a link which will help you with this. So yeah, and just quickly, data in other formats from retailers and some smartphone applications on your electricity usage cannot be currently used in SunSpot. This is a future area of development. And so yeah, just on that website, on the landing page, you'll see those menu icons at the top. If you go into help using SunSpot, there is advice and links on SunSpot's website about how to request this data from your DNSP, which is just your distribution network service provider. Typical ones being Ausgrid in Sydney, Essential Energy in New South Wales, and they vary in each state. But you can find out from your electricity bill, which we also explain here, which DNSP is yours, and then you can just go back to that page, and there's usually an online meter data request form, which is really easy to fill out. This isn't just to also reiterate, this is not an essential thing to use SunSpot. It's just an additional input you can do to get a more accurate result. But yeah, and so as I just touched on, there's also a link to understanding your electricity bill inside that help using SunSpot. And then among these other menu options in that help using SunSpot menu, you'll also see other support, including FAQs, advice, and then how to use SunSpot in a video format, like Ellie has just gone through. And then, as you also may have seen, and Ellie did allude to them, throughout the SunSpot tool, there's heaps of useful information. You can hover over an information icon, click on the learn more, and there's heaps of more information about how you can use the SunSpot tool and the additional information that you can access. Following this webinar, we'll also send a follow-up email to you with our top 10 tips for choosing a solar installer. Secondly, the information about state-based solar rebates. And then lastly, an email link so that you can ask your local council to provide your area with the premium version of SunSpot.